class, so this podcast has to do with trends again, but now instead of just trends in size, it's kind of a subset of that. Trends. Instead of trends in size, we're going to do trends in ionic size. Alright, so really what we're doing now is we're going to compare anions to their atom and cations to their atom. So if I wanted to know is magnesium or magnesium ion, and again we know it's an ion because it's going to have a +2 charge, which is larger? Okay, so the way we're going to do this is magnesium, doesn't matter which one I have, but magnesium has 12 protons. If we're talking about magnesium atom, it has 11 electrons. And if we're talking about magnesium ion, it has 10 electrons. How come? Because it has a +2 charge, which means it lost 2 electrons. So if we look at this based on size, again, they both have 12 protons, but this one has really 1s protons, 2s protons, 2p protons, and 3s protons. However, our magnesium, because it's lost 2 electrons, it only has 1s electrons, 2s electrons, and 2p electrons. How come? It lost the 3s. So very easily you can see which one's going to be larger. Our atom is larger, and our cation is smaller. And then cation is smaller. How come? Because in losing electrons, it loses those outermost ones, so it looks like a noble gas. Alright, we kind of talked about electron configurations. Atoms lose or gain electrons so that they look like a noble gas. Well, metals tend to lose, so cations will always be smaller than the regular atom. Okay? So just write that somewhere. Cations are smaller than the atom they come from. And that will always be true. Right, if we look at another example, and let's just do, we'll do oxygen. So oxygen, or whenever oxygen has a -2 charge, we change its name to oxide. Okay, so oxygen has 8 protons, and oxygen has 8 electrons. Oxide has 8 protons, but has a -2 charge, which means it has 10 electrons. So again, same question. Now, oxygen has 1s electrons, it has 2s electrons, it has 2p electrons. Similarly, oxide has 1s electrons, it has 2s electrons, it has 2p electrons. So now we can't just decide on which one has fewer orbitals, because they both have the same orbitals that they're filling. So now it's really based on what can the proton attract. So over here with oxygen, we have 8 protons that are attracting 8 electrons. And that's what is normal for oxygen to do. For oxide, we have 8 protons that are attracting 10 electrons. So the question is, who can attract the electrons more strongly? 8 protons attracting 8 electrons, or 8 protons attracting 10 electrons? The larger one is obviously going to be the oxide. How come? Because there's more electrons for them to attract, so they cannot attract them as strongly because there's more electrons, which means our oxygen atom will be smaller. So we can summarize this by saying our anion will always be larger than our atom. How come? Because the anion has extra electrons, and it's the same number of protons, so the same number of protons can attract more electrons more strongly. They attract them less strongly, so they're not as attractive, which means they're bigger. They kind of puff out. The other way to think about this is, what do electrons do? They repel each other because they're all negative. So in that sense, if we have 8 electrons or 10 electrons, 10 electrons are going to have more repulsions than 8 electrons. So again, the electrons themselves kind of force each other out, and those protons can't attract them as strongly either. So really 2 reasons why anions are always larger in size than atoms.